Welcome to this deep dive into some really interesting machine learning research.
Glad to be here.
Today, we're looking at a paper called A New Benchmark for Few-Shot Class-Incremental Learning, Redefining the Upper Bound. Now, that's quite a mouthful, I know, but the idea behind it is, well, pretty important for anyone working with AI, especially when getting new data is tough.
Yeah, definitely.
We're basically looking at a study that asks, are we measuring progress correctly when we teach AI to learn new things from just a tiny handful of examples?
Exactly. It zooms in on this specific area, Few-Shot Class-Incremental Learning, FSCIL for short.
Right.
Think about it like this. You have an AI that knows loads of animals. Then suddenly a new species pops up.
Okay.
But you've only got, say, 5 pictures of it. FSCIL is all about teaching the AI this new animal without it forgetting the old ones.
And crucially, with very little data.
Precisely. And that's much harder than the usual incremental learning where you might get, hundreds of new examples.
Okay, so let's get into the paper's main point. They start by questioning something that's been like a standard assumption, right? Using joint training as the best possible outcome.
That's the one. In, let's say, regular class incremental learning CIL, where you have more data for new classes, training a model on everything together, old and new, that kind of makes sense as your upper limit.
Yeah, it helps avoid that catastrophic forgetting problem.
Right. And it usually does a decent job keeping the different classes, tasks, whatever you call them, separate.
But this paper says that doesn't really work for FSCIL.
Exactly. That's the core insight. Because in FSCIL, you have this massive imbalance. You've got tons of data for the original classes.
The base class.
Right, the base classes.
Yeah.
And then just a tiny trickle for the new incremental classes.
So when you just mix it all together.
The old data just completely overwhelms the new data. It's like trying to hear a pin drop during a rock concert.
Yeah, okay.
The paper argues and shows that this imbalance messes up the model's ability to draw clear lines between the old and the new stuff. The decision boundaries get really blurry.
They actually visualize this, don't they? Showing how the classes get muddled in FSCIL joint training compared to standard CIL.
They do, and they back it up with confusion matrices.
Yeah.
You see way more errors, specifically false positives for those new incremental classes when using standard joint training in FSCIL.
So the model is basically saying, this new thing looks kind of like that old thing I know really well.
Pretty much. It just hasn't seen enough of the new class to learn what makes it truly distinct. It fails to separate them properly.
Okay, so if joint training, the sort of train on everything approach, isn't the ideal here, what should we be aiming for? What's the alternative benchmark?
Well, this is where the authors get clever. They propose a new benchmark. It's still based on joint training, having access to all data, but it's a smarter joint training.
Smarter?
By actively tackling that class imbalance problem head on, they basically say, okay, let's assume we have all the data, but let's use techniques specifically designed for these imbalanced situations.
Ah, so they bring in tools from the world of imbalanced learning.
Exactly. They dive into that whole area, looking at things like resampling.
Like maybe duplicating the few examples of the new classes?
Yeah, oversampling the minority classes, or reweighting, where you make the model pay more attention when it gets a rare example wrong.
Okay.
And even using different kinds of optimizers, ones that are maybe less sensitive to the dominant classes during training.
They looked at a bunch of these.
They did. They didn't just guess. They evaluated 8 different state-of-the-art methods for handling imbalanced data, resampling ones, reweighting ones, optimizer-based ones.
They found a winning combo.
Through, a random search experiment, they landed on a specific mix. It involved a resampling method called CMO,
Okay.
a reweighting technique called balanced softmax, and a specialized optimizer called IMSAM. That combination seemed to work best for this FSCIL joint training scenario.
And they tested this rigorously, like showing each part helps.
Yep, they did ablation studies, took out each component one by one to show that, yes, the resampling helps, the reweighting helps, and the optimizer helps. They all contribute.
And the results. Did this new benchmark actually perform better?
Significantly better, yeah. Compared to the standard naive joint training, their imbalance-aware joint training benchmark showed much higher accuracy, both in overall average accuracy and also in what they call generalized accuracy.
Which gives more weight to how well it does on the new harder classes, right?
Exactly. It gives a more balanced picture when you have that huge class disparity. Their new benchmark consistently topped the standard one.
Okay. That's a pretty big finding.
Yeah.
But they didn't stop there, did they? They also looked at how people have been evaluating FSCIL methods in general.
No, they didn't. And this is, I think, just as important. They basically audited the existing literature.
And found some problems.
Quite a few inconsistencies, yeah. They identified 4 main issues that were making comparisons between different FSCIL methods difficult, maybe even misleading.
What kind of issues?
Things like test set leakage, accidentally letting information from the test data seep into the training phase in some studies.
Ooh, that's a classic problem.
Definitely. Also, just inconsistent training lengths. Some methods trained for way longer than others, different data pre-processing steps, like using powerful augmentations like auto-augment sometimes, but not others.
Right, so not comparing apples to apples.
Exactly. And the 4th one was about using pre-trained models like powerful encoders, sometimes without really accounting for the advantage that gives. An unfair comparison, basically.
That really muddies the waters if you're trying to figure out which new idea is actually working better.
Totally. If the experimental setups aren't the same, how can you trust the rankings?
So what do they do about it?
They proposed and implemented a standardized evaluation protocol, like a common set of rules for everyone to follow.
Okay, what did that involve?
Setting up a new, clean validation set, making sure training procedures like epochs and optimizers were consistent. And crucially, they re-implemented 8 existing FSCIL methods themselves.
Wow, that's a lot of work.
It is, but it meant they could run all these methods under the exact same conditions using their unified framework. A truly fair comparison.
And did that change things? Did the rankings of those methods shift?
They did. That's one of the key results. When evaluated consistently, the relative performance changed. Methods that look like top performers in their original papers maybe didn't hold up as well under this standardized protocol.
That really highlights how critical consistent evaluation is.
Absolutely. It shows that some of the perceived progress might have been down to, well, differences in experimental setup rather than just the core idea.
And how did their new imbalance-aware joint training benchmark fare in these standardized tests?
It consistently performed the best across different data sets, CFAR 100, Mini ImageNet, CUB 200, and across multiple incremental learning sessions or steps. It outperforms standard joint training and all the reevaluated FSCIL methods.
Even considering things like compute cost.
They looked at that too, a resource-aware comparison. They plotted performance against training time and model complexity, FLOP's parameters.
And
their analysis suggests something interesting. If you do still have access to the old base class data, using their smarter joint training approach is actually often better, maybe even more efficient overall, than using these specialized FSCIL methods that are designed to work without revisiting old data.
That's a bit counterintuitive, maybe. You'd think the specialized methods would be the way to go.
Well, it highlights the power of addressing that imbalance directly if you can use all the data. The specialized methods are crucial when you absolutely cannot store or retrain on old data, but this suggests there's a trade-off.
Let's maybe take a step back for context. How did we even get here? Deep learning started with big static data sets, right?
Right. Massive success there. But the real world isn't static. Things change. New information comes in.
So we needed models that could learn continuously.
Exactly. Which led to class-incremental learning, primarily focused on tackling that catastrophic forgetting problem.
And the idea of an upper bound, like joint training, was important there.
Very important. It was the theoretical best. You know, if you didn't have the constraint of learning sequentially, what performance could you get? It gave researchers a target.
But then came FSCIL, Few-Shot, and the game changed.
Precisely. The assumptions from standard CIL, especially about that joint training upper bound, just didn't quite fit anymore because of that severe data imbalance.
It forced a rethink.
It did. It showed you can't just port ideas over without checking the underlying assumptions. And this paper really connects that FSCIL challenge back to the broader field of imbalanced learning.
Using established techniques from there, like the resampling and reweighting.
Yeah, those techniques aren't new in themselves. But applying them systematically to define a better upper bound for FSCIL, that's the key contribution here, alongside the call for standardized evaluation.
Okay, so boiling it down, key takeaways. 1, standard joint training isn't a great benchmark for FSCIL because of the imbalance.
Right, it's unrealistically low sometimes.
2, making joint training imbalance aware gives a much better, higher benchmark.
A more meaningful target.
3, Past FSCIL comparisons might be shaky due to inconsistent evaluation.
Definitely need caution there.
4, we need standardized protocols for reliable progress. This paper offers one.
Crucial for the field.
And 5, this new benchmark and standardized evaluation gives us a clearer picture of where things actually stand in FSCIL right now.
Well, summarized, it really reframes the landscape a bit.
All right, let's move to our novel notions segment. Thinking beyond the paper, they found a good mix of imbalance techniques via random search. What if we could make that more dynamic?
Ooh, interesting. Yeah, research idea 1 perhaps. What if we use meta-learning?
Meta-learning how?
Well, instead of a fixed recipe like CMO plus balance softmax plus IMSAM, could we train a meta-learner to figure out the best way to balance base and incremental classes during joint training?
So it would adapt its strategy.
Exactly. Maybe it looks at the incoming few-shot data, how many samples, how similar they are to old classes, stuff like that, and then it tunes the imbalance parameters on the fly.
Like adjusting the resampling rate or how much weight to put on errors for the new class?
Precisely. It would learn how to handle the imbalance for the specific data it's seeing right now. That could, potentially lead to even better results and maybe generalize better across different kinds of FSCIL tasks.
Because the balancing act would be tailored each time.
Right. It leans on the success of meta-learning in other few-shot areas and the clear benefit of handling imbalance shown in this paper. Seems like a plausible next step.
I like that. Very adaptive. Okay, what's your second idea?
Research idea 2. This paper tackles the consequences of having few shots. What if we tried to tackle the lack of shots more directly, using generative models?
Like generating fake data for the new classes.
Sort of, yeah. Could we use something like a GAN, trained on those very few real examples, to synthesize more plausible examples of the new classes?
And feed those synthetic examples into the joint training process.
Exactly. The idea would be to artificially boost the number of samples for the incremental classes, trying to bridge that gap in the feature space between the many base examples and the few new ones.
Helping the model separate them better.
Potentially, yeah. It could complement the imbalance techniques they used. Instead of just reweighting or resampling the few real examples, you'd be adding more diverse, synthesized examples.
Sounds powerful, but tricky to get right.
Oh, definitely. Big challenge. Ensuring the generated data is actually helpful and realistic and doesn't mess up learning for the base classes or introduce weird biases. You wouldn't want it generating confusing noise.
Yeah, you'd need high-quality generation.
For sure. But there's work like Deep Smote in standard imbalance learning that uses similar ideas. So applying and adapting that kind of generative approach within the FSCIL joint training context, that could be another interesting avenue.
Those are 2 really thought-provoking directions. Makes you think about how many different ways we could approach this core challenge.
Absolutely. And again, just a quick disclaimer, these are speculative ideas for discussion. Making them work would require, actual research and validation.
Understood. So wrapping up our deep dive today, the main thrust of this paper is really about setting a better standard.
Yeah, challenging that old upper bound idea in FSCIL and saying, we need a more realistic target and we need to evaluate everyone fairly against it.
It's a vital piece of work for anyone interested in AI that needs to learn continuously, especially when new information is scarce.
Definitely pushes the field towards more rigorous and hopefully more rapid progress.
We really encourage listeners to check out the paper itself, links in the description if you want the full details.
It's worth the read.
And maybe a final thought to leave everyone with. As AI gets woven more deeply into our changing world, how do we ensure our benchmarks keep pace? How do we make sure we're measuring the adaptability and lifelong learning skills that truly matter? Something to ponder. Thanks for joining us on this deep dive.
Thanks for having me.